Algebra 2. This is Unit 4, Lesson 3, and today we're going to talk about exponential functions. So an exponential function has an x in the exponent, right? Again, the x is the exponent. That's what I'm substituting in. That's going to be my input. So those exponents are going to be changing each time. So I need to change these notes. This first thing should say if b is greater than 1. So if b is greater than 1, change that 0 to a 1, then the function is an exponential growth. It's going to be increasing. So if b is the number that's being raised to the exponent. If b is greater than 1, then it's exponential growth. It is increasing. Sorry about that. If b is a fraction, so if b is less than 1 but greater than 0, then the function is an exponential decay. And that means it's decreasing. And we're going to do one of each of these so that you can see what they look like. So we're going to try and fill in the table without using our calculator. We're going to do y equals 2 to the x. So it's a nice easy one that you don't actually need your calculator for. So basically, if x is 0, 2 to the 0 power is 1. If x is 1, 2 to the first power is 2. If x is 2, 2 squared is 4. If x is 3, 2 to the third power is 8. The negative ones, remember, in order to make a negative exponent positive, I put it underneath 1, so it's 1 over 2 to the first. This is 1 over 2 to the second. And this is 1 over 2 to the third. To make that negative exponent positive, I put it in the denominator of a fraction. So 0, 1 is a point, 1, 2 is a point, 2, 4 is a point, and 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the fraction ones you just have to estimate. So I got negative 1, 1/2. Negative 2, 1/4, negative 3, 1/8. So it's never going to touch 0. It's just going to get closer and closer and closer to 0. And then I'm just connecting these points. This is what a exponential growth looks like. Okay? Is it a function? Well, does it pass the vertical line test? Absolutely, yes, it passes the vertical line test. Is it 1 to 1? That means does it pass the horizontal line test? Yes. The x's and the y's, neither of them are repeating. The domain are my x's, so I want the leftmost point. It never ends. It keeps on going. It has an arrow. The leftmost point is negative infinity. Now I look to the right. Is there a rightmost point? Nope. Again, it never ends, so it's positive infinity. The range of the y's, that's up and down. Is there a bottommost point? Well, it is approaching 0. It never touches 0, so it's going to be 0, but I'm not including the 0, but it will get closer and closer. Is there a topmost point? Nope, there's not, so it's infinity. The x-intercept, is it intercepting the x-axis? No, it's getting closer and closer to it, but it's never intercepting it. And the y-intercept is 1. Is it increasing or decreasing? It is increasing. Okay, so this is an exponential growth. It's increasing. B is greater than 1 because I have y equals 2 to the x. 2 is my b. Let's try one where b is less than 1. So it's greater than 0 but less than 1. So I have y equals 1/2 to the x power. Now this one we can use our calculator for. All right, so you're going to go right to your calculator and you're going to do y equals, let me just erase these. I was just playing around and do some other ones before. 1/2 to the x power. So if you know that 1/2 is 0.5, you can do that. If you just want to do 1 parentheses 1 divided by 2, and then I hit this up arrow that's above the division, and that's going to give me my exponent, and my exponent is x. You can look at the graph so we can see what it looks like. See how it's decreasing? It's approaching 0. It's never going to touch. It looks like it's touching, but it's not out there if I was to zoom in. Let's look at the table. So my table right here. And I had points from negative 3. So negative 3 is 8. Negative 2 is 4. Negative 1 is 2. 0 is 1. 1 is 0.5, 2 is 0.25, 3 is 0.125, so it's getting closer and closer. But if I were to scroll down, you can see it's never ever actually going to touch 0, okay? And this right here is not 6, okay? It's just getting closer and closer. That's going to be to an exponent, that number. So let's look right here. Let's go back and let's fill in my table. So again, -3 was 8, -2 was 4, -1 is 2, 0 is 1, 1 is 0.5, 2 is 0.25, and 3 is 0.125. So I'll plot those. -3 is 1, 2, 3, 4, 5, 6, 7, 8. -2 is 1, 2, 3, 4. -1 is 2. 0 is 1. Half, a quarter, an eighth. It's actually just going in the opposite direction of my other one. It's close, gets closer and closer to 0. Something interesting to point out, both of these points go through 0, 1. They both have a y-intercept of 0, 1. Okay. Is this a function? Absolutely. It passes a vertical line test. Is it 1 to 1? Does it pass the horizontal line test? Yes, it does. The domain is the same, -infinity to infinity. The range is actually the same also. So it's the lowest most point is almost 0, but it's not including 0. And the highest most point is infinity. Again, there is no x-intercept. The y-intercept is 1, but this one is decreasing. Now I have the word asymptote, and that's an important word that we're going to define right now. An asymptote is a line that a curve approaches as it heads towards infinity. It's a line that a curve approaches as it heads towards infinity. But it never touches it. Okay? For our exponential graphs, that asymptote is always going to be the x-axis, or y equals 0, unless I do a vertical shift. Okay? Unless I'm doing a shift. All right. All exponential equations go through the point 0, 1, unless there is a transformation. Okay, why is that true? Notice that these all went through the point 0, 1. This one was 0, 1. This one right here was 0, 1. Okay, unless there's some sort of transformation, that's always going to be true. And the reason is any exponent to the 0 power equals 1. So like say I have 5 to the x. When x equals 0, 5 to the 0 equals 1. All right, so unless there's going to be any kind of shift, that is always going to be the case as well. All right, are exponential functions 1 to 1? How can you tell? What does this tell you about their inverses? Remember, in order to be 1 to 1, the x's and y's can't repeat. Are exponential functions 1 to 1? Yes, they are. They pass the horizontal line test. The x's and y's don't repeat. What does this mean for their inverses? Their inverses will also be a function. So the inverses will be a function. Okay, so I'm going to do a graph on 4. But not actually do a graph. That'll make sense in a second. I'll do like a little sketch. So let's consider the function y equals 7 times 3 to the x. So b is 3, but I have a coefficient in front. Because remember, I started off by saying a times b to the x. Let's determine the y-intercept of this function algebraically. So remember, my y-intercept is when x equals 0. So I'm going to plug in 0 for x. Well, anything to the 0 power is 1, so 3 to the 0 power is 1, but then I have 7 times 1 is 7. All right, so that's going to be my y-intercept is going to be 7. So I'm just going to make a 7 here, and I will have a y-intercept of 7. Does the exponential function increase or decrease? Explain your choice. Well, remember, if b is greater than 1, which it is, it's 3, then it's going to be increasing. It's increasing because the base is greater than 1. Okay, so increasing means it's going to go like this. Let's create a rough sketch of this function, labeling its y-intercept. Okay, so here's my y-intercept is 7, and I know it's increasing, so here's my rough sketch. Done. That's it. All right. Consider the function y equals 1/3 x plus 4. How does this function's graph compare to that of y equals 1/3 x? What does adding 4 do to a graph's function? Well, let's look at my graphing calculator. So take out my graphing calculator. I'm going to erase this one. So I have parentheses 1 divided by 3 to the x. And then I have parentheses 1 divided by 3 to the x. Get out of exponents, plus 4. So let's look at these on the graph. So the blue one is y equals 1/3 to the x. It's going through the point 0, 1. And the black one is just shifted up. Okay, so by adding 4, I am shifting the graph up 4. All right, so how does the function's graph compare? We just looked at it. It will shift the graph up. And we learned about these transformations already. We're going to sum them up again at the bottom. It will shift the graph up 4 units. Okay? Determine this graph's y-intercept algebraically. So I got y equals 1/3 to the 0, because the y-intercept x is 0, plus 4. Well, 1/3 to the 0 is just 1, but now I'm adding on 4. So this is now going to have a y-intercept of 5. Create a rough sketch of this function, labeling its y-intercept. So remember, this has a base that is greater than 0 but less than 1, so this function is decreasing. It's decreasing, and it's going through the point 0, 5. So here I can have 5 right here, all right? And it is decreasing. It gets smaller and smaller, whoops, but it's never going to go, whoops, it's never going to, it's going to approach the line y equals 4. Because if I look back on my graph right here, all right, see how it's not approaching 0, it's approaching the line y equals 4. The black line is the graph. All right, so it gets smaller and smaller as it approaches this line y equals 4. It's never going to touch it, just like the asymptote on the other graphs where y equals 0. This asymptote is y equals 4. And at the bottom, I have my summary of all my transformations. All right, so here's my summary. Transformations on the exponential functions. They're just like the absolute value ones that we did. If I have a negative in front, what does that mean? Does everyone remember that's a reflection over the x-axis? If I add or subtract to the x, so it will be up in the exponent with it, then that's going to be a shift left or right. And remember, if it's negative, I am going to the right. If it's positive, I'm going to the left. And then if I just have another number, just like the one I did, then that's moving it up or down. And you can always do these in the graphing calculator to confirm. This should say down, up or down. So it moves it up and down. All right, let's just look at a few equations on the back with no graphing whatsoever. So we want to describe the transformations in words that's happening. So f of x is e to the x. We're going to talk about e probably in a week or so. E is a natural exponential function. It's an irrational number like pi. It's approximately 2.71828. It's named after Euler. But so e to the x and e to the x plus 3. What does this 3 do to the graph? Well, that 3 shifts it up 3. If it shifts it up 3, and they also want me to state the horizontal asymptote. So for a normal exponential graph, the asymptote, the line that it approaches without touching, is y equals 0. But if I'm shifting this up 3, then it's going to have a asymptote of y equals 3. All right, how about on 2? What does it do if I subtract 1, if it's 10 to the x minus 1? Remember that if it's attached to the x in either an absolute value or an exponent or parentheses, it's going to be a shift left or right. Since this is -1, I'm going to shift 1 to the right. Now shifting it left or right will not change the asymptote. It will still have an asymptote of y equals 0. This negative sign right here, that is a reflection over the x-axis. Again, that will not change the asymptote. The asymptote will still be y equals 0. It will just be on the other side. It will be in the negatives, but it will still approach 0, but just from the bottom, not from the top. And I got two things happening on number 4. So think about them. The 2 is attached to the x, so that's a shift that's going left-right. So that's going to be a shift of 2 to the left. And the 4 is going to be a shift down 4. Now, since I'm shifting it down 4, I'm definitely changing that asymptote. My asymptote will not be y equals 0, it will be y equals -4. Just this next one has sort of a review based on things that are going on. The graph is already done for us. So just to go over some things, is it a function? Well, does it pass the vertical line test? Yes, it does. Okay, so exponential functions are functions. It passes vertical line test. Is it one-to-one? Yes, it does. One-to-one means the x's and the y's do not repeat. Just if you have a graph, look to see if it passes a horizontal line test. The domain are my x's. The leftmost point, it has an arrow. The rightmost point has an arrow. They are going on forever and ever to the left and the right. I know it looks like it's going up, but it's actually going up and a little bit to the left at the same time. So my domain is -infinity, infinity. My range are the y's. What's the lowest most y point? Well, you can see that this is 4 right here. It's approaching 4. That's the asymptote. But so I'm going to write 4, but use a parenthesis because it doesn't actually equal 4. And the topmost point, I have an arrow right there. There is no topmost point. Is it intercepting the x-axis? No, it's not. Is it intercepting the y-axis? It sure is, right here at 6. My asymptote is the line that it's approaching but never touching. The one that I just drew right there is y equals 4. Where is the graph increasing? Increasing means it has to be going up. It's not increasing anywhere, so never, or you can write brackets with nothing in them. Where is the graph decreasing? It's decreasing the whole way, all the way from -infinity to infinity. Where is y less than 6? Okay, so this is purple dot that I have. That's where y is equal to 6. It's less than 6. The whole rest of the way, it's less than 6. So it's less than 6 everywhere from 0 to infinity. Not at 0. At 0, it equals 6. Okay, but from 0 to infinity. Is this graph growth or decay? It's going down. It's decreasing. It's decay. Look at the b value. That b value is a number that is greater than 0 but less than 1. It's a fraction. And average rate of change. So the average rate of change would be f of 4 minus f of 0 over 4 minus 0. So it's similar to slope. It's a change in y over the change in x, but you have to actually find the value of the y value. So f of 4 minus f of 0. So I'm going to put this in my graphing calculator in order to do this. So if I go to my graphing calculator and I go to y equals, so I have 1/2, so parentheses 1 divided by 2, okay? and the exponent is x minus 1. X minus 1. Now to get out of the exponent mode, I'm going to do this arrow to the right so it brings it back down, plus 4. Okay, you don't want to write the 4 until you're out of that exponent mode. Second table, because I'm looking at the table, and I want to know f of 0. So f of 0 is 6, and I want to know f of 4. f of 4 is 4.125. Okay, so f of 4 is 4.125, and f of 0 is 6. So I'm doing 4.125 minus 6 over 4 minus 0 is 4. And if I do that in my calculator, I get negative 0.46875. And that is my average rate of change over that interval, because this is not a linear function. So that changes depending on what interval that you're talking about. All right. The next page, I have a little summary